This question you'll find in fourth unit from the same question paper. This question is from fourth unit. So write the algorithm for solving n queen's problem using backtracking. I told you many times while I am taking the lectures of DAA subject, please don't leave this topic. Backtracking and branch on bond from fourth unit. These are direct questions. Please don't leave for any reasons. Prepare this backtracking approach and n-queen problem strategy. So the question is what? You have to write the algorithm for solving the n-queen's problem. You need not to find the solution. Did you notice this? They are not asking you to solve 8 queens problem or 4 queens problem. No, this is not part of the question, but I'll tell you how to solve if the question is something like that. So the question is what? You have to write the algorithm for solving the n queens problem using backtracking. Now, so the answer should be what? N queens problem definition you have to write first of all. The definition is what? It is a classic problem in which the goal is to place n queens on an n by n chessboard such that no two queens threaten or attack each other. This means that no two queens can be placed in the same row, same column, same diagonal. So here most of the times you will find the same question with other name. That is what? What are the implicit constraints? Implicit and explicit constraints of backtracking approach or n queens problem. Implicit constraint is what? No two queens under attack. That means there should not be no row, no column. So explicit constraint is what? No diagonal. Now we'll see the algorithm how it will be. So algorithm is what? Algorithm n queens k comma n. Using backtracking, this procedure prints all possible placements or positions of n queens on an n by n chessboard so that they are non-attacking. Now for I is equal to 1 to n do, if place k comma I, then we will place x comma k is equal to I. So what exactly this algorithm will teach you is, now let's see, I wanted to place the first queen in the first grid. That means here. If I wanted to place the first queen in this grid, now you will be having the other possibilities, right? So let's see, this is what your root node. Now I have placed the first queen. I have to place second. So backtracking is what? Depth first approach, correct? Now, so you place the first queen. Then what else you can do? You can place the second queen. You can place third queen. You can place fourth queen. See that there should not be any violation in implicit and explicit constraints. So what we'll do? Once after you place q1 over here, q1 over here, q2 you cannot place over here, you cannot place over here, you can place over here, correct? Because it will be same column if you place, it will be same diagonal if you place. So we'll go to here. When q2 is here, you can place q3 here. No, I mean you cannot place anywhere q3, because if you place q3 here, q1 and q3 will be same column. If you place here, same diagonal. If you place here, same column. If you place here, same diagonal. So what we'll do, we'll backtrack it. We'll backtrack it and we'll change the place of q1. So q1 will move to the next place. Okay. So this is what step by step procedure you have to write. If the question is solve 8 queens problem or 4 queens problem. If it is the question, then you have to draw this grid and write step by step. But fortunately you didn't have this question in this question paper. They asked you to write only algorithm. So algorithm is enough. And we will be writing even this lines of information to understand better way how that queen will be get placed. Okay. So this is about your A question from 4th unit. Now let's see in the same question paper what is the B question. B question, that is 5th B. Now, so it is time taking question actually. So my sincere advice to all the students is what, as soon as you find these kind of problem solving questions in the question paper, first to solve these questions. Okay, you, it is very better and better solve the answers in such a manner. First attempt all part A questions. This is what a common phenomena in solving the BTech papers or BE papers. So when you find the question paper, you solve all part A questions. If you do not know something, you just leave the place and come back once if you get some idea to write the answer. Attempt all part A questions first of all. Then immediately switch. Make sure that you complete this part A in 30 minutes. First 30 minutes you please spare to write all the answers for part A. And part B, you have to take more time. Don't waste your time for this paper, because you know how much time can get consumed by each problem solving strategy. As far as this problem is concerned, you will take much time over here. Minimum 20 to 25 minutes will get utilized here in this solving. Now let's see this one. So the question is what, explain traveling salesperson problem and solve. This point is important. When you have a question, when you have a keyword of solve in the question paper, you have to take the example to solve or find the solution for the problem. So what you have to solve, traveling salesperson problem you have to solve using what technique, branch and bound, which is least cost branch and bound. So you given with only this matrix, I drawn this graph. You given with only this matrix. First of all, what you have to do is, branch and bound strategy is different in order to find out the shortest path of traveling salesperson. That you have to find out the reduction cost. That reduced cost or reduced matrix you have to find out. So how you have to find out reduced matrix? Find out the smallest element from each row. Find out the smallest element from each row. Now subtract this element with all the elements from each row. Then you will get this matrix. Correct? You will get this matrix. Now this matrix is called as reduced matrix, row reduced matrix. Now add all these elements, you will get 55. Okay. Now after you get this 55, after you write this reduced matrix of row, find out the minimum element of column. After you find out the row reduced matrix, then you please find out here in this minimum value from the column. Then it will be added, which is 20. Row reduced is 55, column reduced is 20, finally it is 75. So it is what, reduction cost we used to say, R, symbolically denoted with R, and this is called as what, reduction cost. Now so this is what reduced matrix what I am going to use, and this is what reduction cost. Keep in mind this. Again we'll come back for the same 75. And this is what cost adjacency matrix. Cost adjacency matrix, reduced matrix, reduction cost. Remember these terms. Now, so the cost of tour may be 75 or more than 75. We'll solve this problem by a state space tree. What is state space tree? Now, let us suppose traveling salesperson wanted to start from one city. So what is LC branch and bound? Whichever edge is having least cost, that traveling salesperson choose to travel. So we will be, now here you got reduction cost. What is reduction cost? 75. Now keep aside. Now take reduced matrix here. Reduced matrix from 1 to 2. You please calculate the cost of it. 1 to 3 cost, 1 to 4 cost. Whichever is smaller, that will choose. Unfortunately, if you got similar cost, here it is 100, here it is 100, if you got something like that, you can choose this or this, no problem. You can choose any of one. But preferably least cost branch and bound will take minimum cost. Okay. So now we will be going to calculate the cost of 1, 2, Cost of 1 comma 3, cost of 1 comma 4. The formula is what? To calculate cost of 1 comma 2, we will take the original cost of 1 comma 2 from this cost adjacency matrix plus reduction cost plus reduced matrix of that matrix. That also we'll see. Now, so you will be going to finding out the cost of 1 comma 2. Make first row and second column, because 1 comma 2 first row second column make infinite, and when you are traveling from 1 to 2 you will not come back to 2 to 1. So 2 to 1 also made as infinite. Now and check whether it is reduced. Reduced means how to check? You have to find out the zero number. If you do not have a zero number, take minimum element and subtract each row element with that element. Now I am taking this matrix, reduced matrix I am taking. So I am making all 1 and second column as infinite. Now is there any minimum element? You have to see in that each row. No, if no minimum element, then you have to take minimum element and subtract the entire row with that element. Now here cost of 1 comma 2, this you have to get from the cost adjacency matrix. So there it is 10, R value, there it is 75. R cap is what? This value. So this is what? 5. And column 1 also you have to find out, right? So that is what? 5. Row minimum is 5, column 1 minimum is 5, totally it is 10. So now R dash is what? 10. So finally cost is what? 95. You have to calculate in the same manner. Cost of 1 comma 3 you have to calculate. Cost of 1 comma 4 you have to calculate in the same manner. So after you calculate this, whichever is shorter distance, that you will travel. Okay. Now, so among these three, which is shortest one? 95, and this also 95. I choose to travel from this. From this means what? 1 comma 2 I am choosing. That means state space tree 1 comma 2. Now after you choose to travel from 1 to 2, which are remaining? You can travel 2 to 3, you can travel 2 to 4. So you have to calculate 2 to 3 and 2 to 4. To calculate 2 to 3, 2 to 4, you have to take this matrix. Now let's go to that matrix. Now 2 comma 3. So this is the matrix what I have taken from the second one. 1 comma 2 result I have to take here. So now, so here R comma 2 value you have to take, which is 95. Now the same 2 comma 4. So you will get this one. Finally cost is 165. Total tour cost is 455. So this is what actually you have to do it. And we'll see the next question. So to see the next question, we'll take other video.